In the last lecture, we developed the equivalent circuit of the transformer consisting of only passive element, resistance and inductance. This is required, as we discussed, to simulate the transformer by any software, because this is required for the analysis of a big system, because transformer is a part of a big transmission and distribution system and also a part of big plant. So, for analyzing that, we represent the transformer by an equivalent circuit. This part resistance R1 is the resistance of the primary, X1 is the leakage reactance of the primary. This R2 dash is actually the resistance of the secondary referred to primary. We call R2 dash is equal to alpha square R2. For the R2 is the resistance of the secondary, when it is referred to the primary, it becomes R2 dash and it is multiplied by alpha square, where alpha square is the turns ratio, that is N1 by N2, where N1 is the number of turns of the primary, N2 is the number of turns of the secondary, which is in turn equal to E1 by E2 and I2 by I1. E1 is the induced EMF at the primary, E2 is the induced EMF at the secondary, I2 is the current flowing through the secondary, I1 is the current flowing through the primary. So, having these resistances, and this is the magnetizing circuit, we call it a shunt circuit, which consists of a magnetizing reactance Xm and a resistance which is accounting for the core losses which occurs due to the flux passing through the core of the transformer. So, this is the equivalent circuit of the transformer. Now, this equivalent circuit we can simplify further if you just notice a very distinguished character of the transformer, that is the current I0 which is passing for magnetization is only a very small fraction of the total load of the transformer. That means, a full load current, if we take 100, then this 100 ampere, then this magnetizing current will be only 2 to 5 amperes. That means, current is very, very small. 2 ampere, generally we call it, in other words, that magnetizing current is only 2 to 5% of the full load current. If it is 2 to 5% of the full load current, its value is very small. You can notice the secondary current I2 dash is actually I1 minus I0. I2 dash is actually I1 minus I0, but I0 is very small. So, we can shift this shunt branch, that means magnetizing branch, from this place, from the center to one side, without disturbing, without compromising the accuracy of the equivalent circuit. We can just shift this magnetization branch or shunt branch to one side. If we do that, this is Xn, this is Rc. If you do that, now you see how simple is the circuit. It consists of two resistance, one is R1, another is R2 dash, another and two inductance, leakage reactance, that is X1 and X2 dash. So, before going further, we can very well say now that this circuit is becoming very, very simple circuit, and this circuit will be just looking, I can say this is looking just only one resistance R and one inductance X, where R is equal to, where R will be equal to R1 plus R2 dash, and X will be equal to X1 plus X2 dash. So, it is just consisting of two branches. One is the shunt branch, another is the series branch, which is consisting of one resistance and one leakage reactance, which is representing the whole leakage reactance of the transformer. This is the resistance, which is whole resistance of the transformer, which is being referred to the primary. With reference to the primary, this is the resistance and leakage reactance. So, with these arrangements, we can now very well see transformer is, this is a branch circuit. Whenever you give, whether you are having any load or no load, transformer always will be consuming this current I0, which will be required for magnetizing the core. When load will be there, load current will be passing through it. Now, you can say from the V2 dash, we know this V2, alpha into V2, this V2 into alpha is actually V2 dash. So, from here I can find out V2 will be equal to, which is actual voltage, that will be equal to V2 dash by alpha. From this circuit, it is very clear that this voltage is V1 here. This voltage, current is I1, or I can say I2 dash. I1 is equal to I2 dash. Same, because this is a series current which is passing through it. So, both the currents are same. When this voltage V1, if you just subtract the impedance drop, the drop across the resistance, drop across the leakage reactance, we will get the terminal voltage V2 dash. And if you just divide V2 dash by the turns ratio alpha, you will get actual V2. So, this is the actual most simplified version of our equivalent circuit, which is used for the transformer. Now, we will have to now find out what is the value of this XM, RC, R and X to utilize this equivalent circuit for the simulation of our transformer. So, in the next lecture, we will find out how to find or how to measure this series resistance, that means this R, series leakage reactance, that is X, and then shunt reactance and shunt resistance, so that we can represent a transformer by these four parameters.